Now we're going to prove Theorem 3 from Rosen, 7th edition 4.1. And I've restated it here. A mod m equals B mod m if and only if A is congruent to B mod m. So in order to prove this, we have to prove it in both directions. We'll first prove it in this direction where we assume that A mod m equals B mod m. And since that's the remainder when A and B are divided by m, I'll just call it R. Now I'm going to apply the division algorithm to A and B. So A is equal to some integer times m plus R, and B is also equal to an integer times m plus R. That capital Z is the integer symbol, and we'll call that by the division algorithm. And now I can do some math with these equations. That means A minus B is equal to S minus T times M, because the R's subtract out. And we know that S minus T is an element of the integers. Well, since A and B is equal to an integer times M, we know that M divides A minus B, and then this is definition of, let's see, of divides. And if M divides A minus B, then we know that A is congruent to B mod M, and that's definition of congruence. All right, so that's the one direction for the proof. Now we're going to prove it in the other direction. And in this case, we assume that A is congruent to B mod M. And we'll just immediately apply the definition. M divides A minus B. Now we'll apply the division algorithm to A and B, only this time we don't know that they have the same remainder, so I'll say A is equal to SM plus the remainder with A, and B is equal to T. If I can do backwards here. There we go. B is equal to Tm plus the remainder for B. And this is the division algorithm. And I'll just do some math. I'll subtract. I'll say A minus B is equal to S minus T times M plus RA minus RB. And by Theorem 1, since M divides A minus B by assumption, and M divides S minus T times M, obviously, then M must divide RA minus RB. Why is that? Well, because M divides A minus B, and M divides this M divides A minus B, and M divides this term here. So M must divide this term here since it divides these two. Now since, oops, zero is less than or equal to RA is less than M, and 0 is less than or equal to RB is less than M, you'll be able to tell that RA minus RB falls within the range of negative M and M non-inclusive. And the only number in this range that is divisible by M is 0. So since I know that M divides RA minus RB, the only number divisible by M in that range is 0, then RA minus RB equals 0. And now I can just say that RA equals RB, which is A mod M equals B mod M. All right. I'm done with the proof. I'll go back up to the top and kind of scroll down slowly so you can see the whole thing.